Hi, this is Russ Dollinger from ScienceGlen. I wanted to go over a very simple little equation, the formation of silver chloride from silver nitrate and sodium chloride. Your teachers have probably shown that to you. To understand how this works, let's go through this. We're going to show the equations, we're going to use the ion flashcards, and we're going to use my new ionic bonding disc model. Let's start with the flashcards. So I've got silver and nitrate here, sodium and chloride. Now, if we flip these over so you can see the back side of these, let me see, get these lined up here. Okay, so silver loses a 5s electron to become Ag+. It's one of the transitional metals. It's a bit weird, but it's always got a charge of +1. Nitrate has got 4 atoms strung together, a nitrogen and 3 oxygens in a trigonal planar arrangement. It's got a charge of -1. This is +1, -1. So the formula on that one's going to be AgNO3. Sodium chloride. Sodium loses 1 electron from the 3s orbital, and chloride picks up 1 electron to become like argon. Okay, and this is Na plus 1 minus 1, so it has a charge of, it has a formula that is of NaCl. To see how this whole reaction works, let's use the Ionic Bond Disc Model. Now, these are 3D prints. The actual model is coming out in May, depending upon shipping and any production glitches and so on like that. You can see this has got a label on it. The actual version is going to have a printed thing. It's going to be printed, and instead of little Velcro, it's going to have silicone rubber there, and it's going to be ultrasonically welded so that they can't come apart. So it's got, if you see, there's a little magnet inside of there, and so they come together. And so I'm going to put this up here a little higher. So now we have silver and nitrate. So again, we've got sodium chloride, and we've got silver nitrate. Now, when you put these in water, anything with sodium is going to be very soluble in water. Anything with nitrate is going to be very soluble in water. So you put these in water, and they dissolve. Now, silver nitrate in solution looks like a clear solution. It looks like water. And sodium chloride, as you know, salty water looks just like water. You can't tell the difference usually. So, but now, once they're in the water, they're wiggling around all the time, and they're clicking on and coming apart, back and forth, many gazillions of times a second, okay? Now, when by chance the chloride happens to hook up with the silver, it sticks on. Now, this will go on and off and on and off and on and off, back and forth, but here's what's going to happen. You're going to get sodium nitrate, and you're going to get silver chloride. Well, silver chloride, so chlorides are generally soluble except with silver, mercury, and lead. And in this case, it's very insoluble. It hates being in the water. The chloride prefers to be with the silver more than it prefers to be surrounded by water molecules. So it comes out of the solution as a precipitate, a solid. And you'll see it as this like white, cloudy stuff as it floating down to the bottom of the test tube or something like that. Now, so this is, now, if you look at this, we started with the sodium. We ended up with the sodium. We started with the nitrate. We ended with the nitrate. Started with the silver. Ended with that. So this is already a balanced equation. We don't need to do anything else. It's already done. It's a simple equation. You don't need to do anything to it. It's already finished. But there's another way to look at this. Let's look at the complete ionic equation. So as I said, when you put these things in water, let's start over again from the beginning. We started with silver nitrate, and we started with sodium chloride, okay? And when you put these in water, it's going to look like this. It's going to be sodium chloride, and it's going to be silver nitrate. Okay, like that, let's say, or like this, put it like that, okay? So we've got a sodium ion, chloride ion, these are going to be aqueous and silver nitrate. That'll be on the reactant side. This could be on the reactant side of the equation. On the product side of the equation, this nitrate's going to go over and be here, back going on and off and on and off, but the chloride will stick on, and so on the product side of the equation, you'll have a sodium ion, and you'll have a nitrate ion. You're going to have a silver chloride as a solid. Okay? So that's the complete ionic equation. Now, there's one more equation that we can talk about, which is the net ionic equation, and we ignore the spectator ions. The spectator ions, by the way, are the sodium and the nitrate. We start with the sodium, we end with the sodium. We start with the nitrate, we end with the nitrate. They're just looking. Those are called spectator ions. Right? Silver chloride, that's a final product. So sometimes the final product is a liquid, but usually we're going to be looking at it and it'll be a solid. In this case, it's a solid. It's coming out of the solution as a precipitate. All right? So one more kind of equation that we look at is the net ionic equation. What does it take to make that final product, that final solid? Well, in this case, it's going to be one silver ion and one chloride ion, and they come together to make silver chloride, and you get the net ionic equation. So these models, I think it really helps. And the feedback I've been getting from students who've used it, in initial tests show a 33 to 44% improvement in understanding. They just get it. It works. And they go, oh, this is obvious. If there's anything else I can do to help, please let me know. I really enjoy helping you guys with this. Thanks so much. And please remember to subscribe